Growing up in the 1980s, I first became aware of special effects as they were then known through sci-fi movies. The Star Treks, Star Warses, Ghostbusters, Back to the Future. You know, the classical works. How did we see out the Millennium Falcon's windows? How were spaceships filmed? And the answer from making of books always said ILM and blue screen. And that was it. But that's not a complete answer. And if you're watching this, then I'm guessing you also wanted to know more. The trouble is, effects companies created their own methods and jealously guarded them. So the whole truth is rarely shared. I know that sounds a bit like a conspiracy, but to illustrate, let me show you this image. This is Phil Tippett and Ken Ralston stop motion animating for Empire Strikes Back. And those clamp stands? In the Disney Plus documentary about ILM, Light and Magic, Ken Ralston admits, George wanted to show the Tauntaun in Empire Strikes Back being shot. We knew no one has a clue how we create these things. And so we decided to do it in a way no one would ever do it, because we knew no one would recognise it. So it's the two of us in there. We brought in some weird gizmos with rulers, whatever we could grab. It was fun and we weren't hurting anybody. If anyone actually knew we were doing it wrong, it showed they actually had some idea how the work was accomplished. It sounds like me just trying to be a jackass, which maybe it was. But it also, through the course of these movies, it is an interesting lesson to learn what the audience perceives and what you really need to do. The documentary series is fascinating and well worth a watch if you have access to it. As Ken says, faking the animation doesn't really hurt anyone, but on the other hand it obscures the truth from a curious preteen. And this video is about blue screen compositing, not stop motion. But finding out how this was done based on articles from the time means that the truth was often similarly obscured. When you ask most industry folks, why blue screen? The answer is often, they are the colours furthest from human skin tone. But that's not a very good answer. When you have blue on film that emits or reflects light with a wavelength of 500 nanometers, and then develop or print this film in black and white using a blue light, then this blue becomes completely white. You can mimic this effect simply by viewing the blue channel in the compositing software of your choice. But in the pre-computer analog days, you can't just turn off the other colours. And for now, let's pretend colour separation overlay for TV production wasn't a thing. That's a subject for another video. So science gets you a black and white blue channel. How do you use that to remove the background? The answer is optical printers. Which is a cool name, really. In the last century, wow, we're almost a quarter of the way through this one and that still sounds weird. In the last century, movies were shot, edited and distributed entirely on film. Everything had to be captured into a final print, and that print was made using film reels, razor blades and sellotape. That's where Premiere Pro's cutting tool icon comes from. Optical printers were first developed in the 1920s as a way to allow combining different strips of film. This was huge for movie production as it meant not everything had to be shot at once, and shots could be augmented later on. Linwood Dunn created the Acme Dunn optical printer and made great use of this in 1933's King Kong. Fun fact, Dunn went on to shoot the original 11-foot Enterprise for Star Trek. If you look into this for yourself, you might stumble across Lin Dunn being used in close proximity to references to the Dunning process. That refers to C.D. Dunning's 1927 patent for a method for producing composite photographs, and not some weird adding ing to Linwood's last name. Before we get into the detail, I think it's best to give you a quick primer in how film works. Photographic film is coated in light-sensitive silver halide crystals. When the crystals are exposed to light, they darken. But a frame of film does not darken as a single block. Each individual crystal darkens depending on how much light it receives. And in this way you can capture the negative of an image. Run the film reel through a camera at 24 frames per second, and you can capture a moving image. Colour film uses different layers of coating for each colour. If you carefully mask out areas of a frame and then shoot, that area of the film remains unexposed. If you then rewind the film, switch over the mask and point your camera at something else, you can have a giant, a spaceship, or someone standing on a mountain. And rather than do all this in camera, an optical printer can be used on new film to combine elements shot separately. They work by having 2 or 3 different strips of film lined up perfectly backlit and shot by a camera, frame by frame. You'll have seen some citations popping up as I talk to highlight where I've learned a lot of this stuff from, but I have to make a specific shout out to Mark Vargo and his video Blue Screen 1980. His video was the first I found to break down the whole process, and his website is packed with tutorials on filmmaking. I also found a talk by ILM's John Knoll, which filled in some of the gaps too. Here's a fake shot I've not actually filmed, but just go with it. It was easier than organising a studio or getting a copyright strike. And here's an optical printer. Obviously not really, I'm using After Effects virtual lights to help explain what happens. We have a light source, one reel of film, a second set of reels for a second film strip. In between there's a lens to focus the first strip onto the second. There's also extra spools so you can load a third strip of film through to bipack cells. A camera is focused on the second strip. If we don't have any masking areas when we combine the film strips, it looks a lot like the screen transfer mode. So what we need to do is get strips of film with black bits on them, which we can then combine. First step, let's reproject the foreground plate with black cards masking out anything in the frame not wanted, the bits outside the blue area, so we get a rough box around what we want. This is known as a garbage matte. It can be done quite quickly, as you can see from this documentary footage. Then this new strip is developed using blue light to produce a blueprint from the negative of the garbage matte. Next, that same negative is then run through the optical printer. With a red light in the projector and black and white film in the camera. That produces a red separation layer, and anything without any red goes completely black. Next, we repeat the process with a green light to get a green separation layer. This is not repeated for the blue separation, at least according to Mark Vargo, although John Knoll suggests a separate blue separation layer is created. The next stage is to load the blueprint and original negative into the front reels together. That's why there are extra reels, and as mentioned, this is called bipacking. This is then combined with a bright red light. When this is shot with black and white film, the result produces our first matte layer, known as the intermatte. At this point, I wondered why they bothered with the red and green and blue black and white separations. Why not just combine the intermatte with the original colour film? Well, it turns out that if you do that, you get blue fringing, but by using the separation layers with their matching lights, this blue fringing is cancelled out. For the blue layer, the green separation layer is used with a mix of blue and green lights. Just using the green separation layer with blue light apparently leads to poor colour reproduction, so a mix of 70% green and 30% blue light is used. The point is that by using the intermatte with each colour separation and appropriate lights, what these days we refer to as spill is mitigated. To summarise where we're up to and what is going to be used going forward, we have 3 colour separation layers, a negative and an intermatte. If we now combine these with the background, we'd still have the screen problem. So now we need the background to have black where the foreground goes. To reverse the intermatte, it is run through the optical printer with a white light and black and white film to produce a holdout. Then this holdout is used with the background film and shot with colour film to produce a background into positive. Now we need a combined colour foreground. To do that, the red separation layer and intermatte, or maybe a cover matte, Mark and John are a bit confusing on this point, are lined up in the optical printer and lit with red light. Then the film in the camera is rewound. The green separation layer and cover matte are lined up, and the camera records again with a green light. The camera is rewound again. The light is replaced with a blue-green mix, and the film records again. Once more the camera is rewound. This time the holdout and background are threaded into the printer, and the camera records for the final time. And that's for one shot! This shot, SB-19 from Star Wars Return of the Jedi, contains 63 separate spaceships, and used 170 rolls of film to achieve. Seriously, no wonder After Effects was invented. I hope you've liked this delve into the history of optical printers. If you're interested in learning more about this, I've left links to both John Knoll's talk and Mark Vargo's video in the description, as well as my other references. This topic has been on my to-do list for the longest time. Obviously I'd love a like and subscription, but I'm more interested in your thoughts about optical printers. I'd especially love to hear from anyone who was involved in the process, of course, and if you can help me fill in any fuzzy bits, I'd really appreciate that too.